Hey everyone, this is DJ Paul, and in this video what I want to do is talk about how and why speaker manufacturers are often lying to you when it comes to speaker specifications. So let me tell you a story. When I was getting started DJing, or at least taking it more seriously over a decade ago, I bought my first pair of active loudspeakers. And I bought a pair that was advertised to have over 3,000 watts in these, 12-inch loudspeakers. And what I was thinking at the time was, okay, more watts means more power. More power means more ability to move air, and more air moved means louder. So therefore, if I want the loudest speaker, I should buy the one with the highest wattage that I can afford. This is what I did, and I ended up buying an inferior product because I didn't really understand how watts, SPL or sound pressure level, and other things worked. And I also didn't understand the ways these things could actually be manipulated to appear larger to just basically sell products. Now, there are a few companies out there that do a good job of trying to be honest about their specifications. They tend to be conservative, or they'll provide real measured results, not these sort of calculated ones. Once again, it's not that the calculated ones can't always be accurate, it's that they're often calculated in a way to seem higher than you should expect in real life. So a few of the companies that come to mind, these are companies that are mainly aimed at professionals who know what they're doing, who can kind of smell out the BS. Companies like Bass Boss, Stanley, Fulcrum Acoustic, all do, I think, a pretty good job of their specifications. And the reason they do this isn't just, to have scientific integrity, but, when these numbers mean something realistic, it can help you plan out when you're designing your PA or planning out a set. You may say, oh, I want 105 dB SPL A-weighted at front of house, which is 95 feet from the stage. And you can actually say, how many boxes do I need to achieve this? And I don't have to worry about distorting or damaging anything if this number that's measured is within the reasonable operating range, or what you should reasonably expect with this speaker. Unfortunately, many, if not most companies, are actually exploiting your ignorance about these things and other things to basically sell you an inferior product. And part of this is they know you're likely not going to be able to A/B their speaker to others. So they basically vastly inflate their numbers, assuming you're going to be purchasing products based on these numerical comparisons rather than an in-person comparisons. In many ways, they're basically taking advantage of your inability to test or validate their claims to sell you an inferior product. And in some cases, they're actually exploiting your ignorance about their testing practices and some of the physics involved when they do this. The problem here is the person who ends up being taken advantage of isn't speaker companies per se. It's actually you or me as a DJ who ends up buying and owning an inferior product. So this is why you see speaker companies advertising, 1,000 watts, which if this is a peak number is actually pretty meaningless. Or they may not tell you the whole story when it involves sensitivity and how this was measured. So let's look at how this can be done so you can be perhaps a more skeptical buyer. My first piece of advice is just stop looking at peak power. It means, in my view, next to nothing. If a single box on a, 120 volt, 20 amp circuit like we see in the United States was really just continuously pulling 2,500 watts all the time, it would actually trip the breaker. In fact, a 20 amp, 120 volt breaker can flip under 2,000 watts continuously pulled. And in some places, they'll even flip around 1,500 watts. So if you can run 5 boxes together, chances are they're not pulling, 5,000 watts each, or at least not continuously. And this is important because you don't need, you don't care about what your box can run for, half a second before burning up. You want to be able to run it throughout the night, throughout an entire show or set. So that's really important as well. Now, of course, you can get these RMS values, which actually calculate these things like crest factor. So it's not unreasonable to have, 2 boxes that each draw 2,500 watts RMS on a single circuit and not trip the breaker. That can be fine, but just be careful when you're expecting that you're actually comparing the peak number. I would say just don't even look at the peak number for that matter, and look at the sort of continuous or RMS power. That'll give you a better idea. Sometimes it's a half, sometimes it's a quarter of what the peak is advertised, and I think that's a much more useful number. The next thing a lot of people like is SPL, sound pressure level. dBSPL is you think this is a scientific measurement that has to do with air pressure. The problem is these numbers can actually be fudged a little bit too. So you got to know the difference between realistic continuous measurements, the sort of industry standard BS that people will sell to you, and then what is simply, I would call, just BS in general. So I saw a product, and I'm not going to name names here, but I saw a product that was advertised. It was a single 18-inch ported subwoofer that was claimed to have 138 dBSPL RMS, which if you add 6 dB to it to get from RMS to the peak value, actually implies, and they advertise, 144 dB SPL peak. And obviously I heard this, and that really piqued my interest. I'm like, oh, wow. I mean, if this can actually do this, then why bring double 18s? Why this can replace 4 other speakers that I have. This sounds great. And as I started looking into it, it had some decent specs, 2,500 watts RMS, 5,000 watts peak amplifier with a 4-inch voice coil. The problem here is we don't know some things about this speaker that could be possibly used to tell us what is going on. So let me talk right now about sensitivity. Sensitivity is a measurement of the driver that basically tells you, think of it like an efficiency measurement. It basically tells you how a speaker is going to turn electrical energy into acoustic energy. And in general, a higher number is better. When you combine driver sensitivity with power handling, where power handling just basically tells you how much continuous power the driver can handle, like an upper limit, you can actually kind of get a more reasonable estimate of what the speaker can produce. So I went to BNC's product line. I was able to find their product line, and I looked here at some of these sensitivity numbers for their 18-inch drivers. And lo and behold, the maximum you're going to see here is about 98 for an 18-inch driver. So what I did is I went over to this website, which you can go to, and you can basically calculate what the SPL is by basically putting in these numbers. Now, if we're doing an 18-inch subwoofer, we can put in 98 dB SPL. The amplifier power, let's go with continuous, 2,500 watts. The distance, I'm going to look at 1 meter because this is the way that the sensitivity is measured in meters, so we need to put in the distance. So 1 meter is 3.28 feet. With one speaker, and I'm actually going to put in a corner. What I want is a 6 dB increase because we're going to be putting it on the floor. So this is what adds a 6 dB increase. In theory, you could do it this way, but this website doesn't know the difference between whether you're using a subwoofer or some sort of top speaker. So let's just do it this way. And we click it, and lo and behold, it appears that we could actually achieve 138 dB SPL at the listening position at, 1 meter away. Hey, it seems like their claim is actually pretty reasonable. Until we get into the real world. And one of the things to realize is that, first of all, the sensitivity is going to drop when you're loading the driver into an actual ported enclosure. The sensitivity is actually going to drop outside of the port tuning range. So if you need this thing to go deep and the ported box is tuned to a specific frequency, you're going to lose a lot of sensitivity. And then basically it's going to drop, the sensitivity will drop due to port compression, which is basically turbulence in the box. And furthermore, as heat builds up in the voice coil, the power delivered to the voice coil may actually need to be limited as well so the thing doesn't melt. So this 138 dB SPL, while you see this on paper, isn't exactly the full story. But if you had seen this, or perhaps you had even seen the 144 dB SPL number, and you thought, oh, that must be obviously superior to a speaker that's rated at, say, 130 dB SPL, if that 130 dB SPL is a continuous real-world measurement, it may actually refer to a box that gets louder than one that claims to have 14 dB more. Let's see why. So you take 144 dB SPL and you first need to subtract 6 to get down to an RMS value. So that brings you down to the 138 that we see. And then of course we can start thinking about how the sensitivity can drop given all these physical real world circumstances. Now, it's difficult to know without actually measuring the box, but that's precisely my point. If you're not able to actually measure the box, if the 130 dB SPL comes from a continuously measured thing, whereas the 144 number, the 138 number comes from some theoretical calculation that doesn't take into account heat and these other physical properties, you may end up being tricked into buying a product that says it gets a lot louder, but in reality may not at all. So this is my second piece of advice. The question you should be asking is not necessarily, will the speaker get loud, but will the speaker get loud, stay loud, sound good while it's loud, and not damage itself or blow up while I'm running it full tilt. As a DJ, we tend to be very hard on our sound system, so it's always good to make sure you have something that's protected and limited. It's good when it's limited, but once again, you don't want to be buying this stuff that just says it can produce this, and the only amount of time it can produce it is just half a millisecond, and after that, the limiter really clamps down and it just starts sounding like garbage. So a few of the things that you should be looking at, I would say, while you're shopping around for speakers and wanting to compare things, would be things like your X-max. This is your maximum displacement of the driver in its linear region, which basically means how far can the driver move, what's the displacement of it, its maximum displacement, and before the sound starts distorting or anything like this. And this is usually expressed in millimeters. So a higher X-max, like 14, that's really good. That means the speaker can move a lot. Obviously, the more air you move, the louder the thing can go. That is true. You can also look at the driver sensitivity and the power handling, which we talked about, and a few other things. First of all, look at the voice coil diameter. This can help understanding how much power can be handled. In general, a larger voice coil means it can handle more power. Some people think the voice coil diameter is the X max or the maximum displacement. That's not necessarily the case, but in general, a larger voice coil can handle more power, which is why you see some companies arguing that their voice coils are, 4 or 4.5 or even 6 in some cases. So keep that in mind. And then what's also really important is the frequency response, is knowing, can it get deep or can it get low? Sometimes people will say, well, hey, my speaker gets 140 dB SPL, but that may be, if you're buying a subwoofer, let's say, that may be at 90 hertz, what you don't really care about. And if it drops off a lot, you can end up with a box that gets louder at deeper frequencies. It's just doesn't have these weird peaks and valleys where you don't want it. So a flat frequency response, I think, tends to be better. The question is, can it get deep enough if you're buying a subwoofer, or if you're buying a top speaker? Is it just kind of consistent? Is it consistent across the top end? There aren't any weird sort of dips and curves that could make it sound kind of wonky as well. So that's something else you should keep in mind. There's a reason most manufacturers don't tell you the sort of sensitivity information or other information about the driver, in part because they may advertise that their speaker can produce 5,000 watts, but that's a measurement from their amplifier, and they're not telling you that their driver can only handle, say, 250 watts or something like this. So who cares if your amplifier can produce 5,000 watts if the driver can only handle an eighth of it or something like that? So just be careful. In general, what I would say, and my advice is to you when you're shopping for speakers, is just be sure you're comparing apples to apples and don't just trust the manufacturer's word for it. I came across a post today on a DJ forum that was asking, is this 1 dB a difference between these two boxes? And I'm like, that is certainly within the BS zone of what manufacturers can claim. But not only that, if you're not comparing the right things, what may seem like an even 3 dB difference or a 6 dB difference could be due to entirely the way things are measured. So just be careful. The gold standard is being able to shoot out the speakers in person. If you can listen to them, if you can kind of run them, not just for a second, but over time, over a couple songs, and see how they handle, that's a lot better. If you care about being a good DJ, I think you owe it to yourself to be educated and to have a good sound. I don't know about you, but you can't be the best DJ with a mediocre sound system that someone sold to you by manipulating you into buying an inferior product. So what I would also say is educate yourself, and that's exactly what you're doing by watching this video, but also don't be afraid to ask questions. There are a lot of people that, want to make sure you're making good decisions, who care about you. Some of these manufacturers may not, they just want to sell their products, but there are plenty of other people, and even other people who work for other manufacturers, who just want you to be happy and want you to learn, so they're more than happy to educate you. I would say be skeptical whenever a manufacturer advises one number at the expense of all others. When it comes to ported 18-inch subwoofer cabinets, there's a sort of physical limit to what one can reasonably expect a single ported 18-inch cabinet to reproduce. So you can get really good results with a good amp, a solid driver with a large X-Max and voice coils, which can handle a lot of power, and just good box design. And that's what I would encourage you to do. Shop around. If you could listen to them in person, do so, and also make sure it can reproduce that volume for a longer period of time, knowing that these numbers don't always tell the whole story. I'll provide a couple links in the description, including the one that I use to do these calculations, so you can kind of do some of them on your own. And happy shopping, and hopefully you can get the best stuff you can. Have a good one.